Should we move on to another topic and get back to Warsaw once our internet and things start working?
Yeah, that might be a good idea. Is Scott Peterson on the second topic? I don't see him in the list here.
I don't see him.
Maybe we can start with the third topic then. More efficient tracing. Gabby, do you want to take it away?
Yeah, sure. So I'll try to share my screen. Hopefully it will work this time. So I tried to prepare a short presentation about performance tracing. So hopefully it will work. So high performance tracing and why we need it. I'm still trying to explain why do we even need this tracing. So the tracing is trying to fulfill something that we don't have in our system. So if you look at a simple system like standalone application, you could use a debugger. If you want to find that something is not working as it should be, then you use a debugger like GDB. The debugger is instrumenting the operation. You can get step-by-step execution. And then online, you could decide if you want to skip a function, if you want to step in, if you want to skip multiple iterations, and so on. You can monitor and modify values in the program variables. And again, online, you can decide which parameters are you interested in. And you can also collect a predefined variable set. And the problem with this mode is that it requires user intervention. The debugger is blocked waiting on user input. So it's very nice if you debug in a simple user application with a single thread of execution. When you go to debug high-performing systems, which can do tens of thousands to millions of I/O per second or operations per second, there's no way a debugger could support this kind of load. Operation will time out waiting on user because in GDB you always have to decide what you will do next. So you have to watch something, you have to see it, and then okay, you step in the next step. But when we do things as humans, it takes us seconds to operate. When the machine is doing millions of IOPS, it's microsecond response time, which of course we cannot compete. So the system would slow down. Every distributed parallel behavior will be broken because the thread of execution timing is different now. And race conditioning and timings would be hidden. Also, in many cases, operation will time out. A lot of network operation, they got very short timeout. If they wait on us, they will never compete. So the way to address this is to use an online tracing. Online tracing allows the system to progress without waiting for the user input. The system collect and keep changes in variables, and the user can review them post-mortem. So you just collect everything and then you replay them. Execution can be replayed later from the collected data, and then the user can analyze the data and find what went wrong. So very simple and basic solution that we all know is something like SYSLOG. Basically, you just add printout to your screen. In the beginning, everything was just printed to the terminal, which of course is very inefficient. Then people come with this great idea of using a logger. So instead of the printing to terminal, you put it to a log device, which is written into memory buffers, and when the buffers are full, they go into sequential files. And later, when you want to search the log for event, you're using all kinds of text utilities like head, tail, grep, less, and so on and so forth. So far, so good. Do you guys hear me?
Yep, all good.
Okay, I got no feedback. I don't know if I'm talking to myself. Okay, so there are a lot of limitation to this simple tracing. So the easiest to see is that they produce either too little information. So you try to find a problem and then you got all this crazy amount of data, but you don't have the information that you need. Or that they got just too much and the system is slowing down and logs are just becoming bigger and bigger. Another problem is that if you want to add event and in runtime, you want to change which event will be used, then you need to print, to add the line, compile, and build every time if you want more tracing or less tracing. Another problem is the overhead. When you do everything string-based operations are very expensive and it takes enormous amount of space. So again, the traces tends to be too big and they run out of the control, and of course everything is too slow. And one thing people don't notice until they actually use a real tracer is that it's almost impossible to follow an execution when you got just strings. Actually, if you want to follow a single IO operation, if you don't have the context and if you don't have type, something which identifies that this is all coming from a single thread of operation, and I don't mean execution thread, I'm talking about logical thread. IO starts here, then it going to these data structures, allocating this buffer, copying the data to this guy, the staging to here, waiting here, all these things, you need something to combine them. And the string themselves, they don't have this thing. So move on. So some workaround for this. So if you want to control the amount of tracing, you need to build the system again. You need to change it and compile. So people added this thing they call trace level. So trace level 1 until 20. Every level, you're going to show more event traces. And what you do in development time, you try to judge which trace event is important, and you assign priority based on that. And you say the most important one would be on level 0 and the least on level 20. But in reality, when you have something not working, it might be something you put on priority 20. And if you put it on 20, it means the whole system going to flood with information. So it's not flexible enough. Then people start using stuff. It's complicated to follow string of execution with just grep and others. So they start using sed, awk, Perl, Python, writing a very complicated script, trying to make sense of all this amount of crazy text they got. So it's complicated. Not everybody is a great script writer, and even the best script writers will find it extremely hard to follow an arbitrary printout and make something out of this. Without type and context, it's just strings. So I'm trying to build a document from an online tracing system. So requirement number 1, it must be simple to operate. If it's not simple, people don't use it. It must be log-free, otherwise it won't scale. If we're talking about now, you could have 50 or even 100 cores running on the same machine. If all of them would take logs each time that you want to put in event trace, it just won't scale. Online tracing system should not impact the normal execution. Again, usually when you have event tracing, so the simplest one is something you do in in compile time. If you could put something, there's a macro, and by compiling this, you remove all of them. So there's zero impact to the performance. But of course, we don't use it because we want some level of control. So we're using this mode of level 0 to 20 or whatever. But even if we denote level 0, which means don't show me any event trace, still, every time the system is going to see a code and the code is going to say, do I need to print this thing, yes or no? It's an overhead. We need the overhead to the normal execution, which is a customer or somebody running performance benchmark. We don't want any overhead coming from event tracing. Data should be, so that's when you're not running. When you do run, data should be collected in efficient binary tracing. But even so, you collect it in binary, it should be still displayed in human readable format. So binary collection for efficiency, human readability. So for us. And we need online filtering of event collection, which is something we don't have in the previous one. I would like to be able to filter by event type. For example, let's say I find there's a problem in my Scrubber code. So I say, this time when you run, even so Scrubber is priority 20, but I'm now trying to debug a Scrubber problem. So please collect only Scrubber event, nothing else. Or maybe Scrubber event and a pglog event, or Scrubber event, pglog, and blue store event. So you can decide which events you want to collect. And you should have a lot of events. So the granularity of filtering will be good. Like the system I've been using, they use 2 bytes for event type. So you could define in theory 16K for event types. In reality, I think people use something like 600. And you should be able to collect and filter by object type. For example, I need to be able to filter by pool ID, PG ID, object node ID, device ID, LBA, block ID, you name it. Or I could say, show me everything which have them, or show me when this thing only pool number 5, only PG number 17, only object node ID X, and so on. So you should be able to have control of how much you collect. So in this time, I'm talking about collection. And by limiting or by filtering in collection, we greatly reduce the impact of the system. It means we need much smaller memory size. And if we create the correct filters, we might be able to fit the whole event trace in memory. And we won't get a slowdown by getting to disk and so on. And then later we need sophisticated tools to view, search the collected trace. We need, again, so there's filtering when you collect the trace because you want to minimize the trace size, but then there's filtering when you view the trace. You try to look for something and say, okay, now please show me just events related to SCSI. Or I just want to see events on the fiber channel or on the network. Show me TCP events, whatever. And of course, the language should be complicated. You should be able to say, I want to see event type X on PGY from client Z, starting in timestamp T, and so on and so forth. So I'm trying now to elaborate. So it must be simple. It should be simple process to add a new tracing point. It should be similar to adding a printf. If it's more complicated than that, people will just not going to add event trace. I mean, you could force to use it in some very critical location, but if you want people to be generous with event tracing, and remember, because we can filter event in runtime, it's good to have more of them. So it should be easy to do this. And I'm actually jumping to the last item here. One thing to make it easy, it should be globally available without parameters. In our system, every time you want to put an event and you don't have it in the object, you need to pass the CCT object down the line from filter. So I've done it in one file, and I had to change, I think, 5 files to get the CCT object just so one function would be able to trace it. And that's change. It means if I just want to trace something here, I need to start compiling the whole system, and it's crazy. Should be like this. The tracer should be a global variable accessible to everybody, and it should be easy, just sitting and waiting for you. So that's how you add event to the system. Then on runtime, it should be easy to add and remove filter online. When you try to trace, you should have easy interface to add and remove filters. For example, you could say, let's say you debug in OSD. So you could say, okay, since I'm debugging OSD, I don't care about everything else. Let's start with default OSD event set. And you could create some events which most OSD developers need. And from this event set, you could then later say, okay, remove this one, maybe add also that one, and so on and so forth. you should be able to add multiple event filters in a single command. You don't want to start issuing one command after another. And of course, if you could have a GUI for this, that's the best. It should be easy to follow and search the collected trace, should be human readable and strong logical language. And again, you don't need people to do crazy scripting to be able to search a trace. The trace should be easy. Log-free operation. So it's actually, this thing is well understood, and you could see this thing on other tools like Jaeger and others. What we do is that every CPU core is running an independent stream of event, log-free, completely log-free. The events are collected into private buffer, can be written by a single core, so you don't need to log it. You can use double buffering, and when one buffer is full, you dump it into a private disk log. So again, you don't need any synchronization because the disk log is dedicated for you. And to be able to merge events, every event is going to have a timestamp. That's very easy if you do it on the same node because all of them are going to share the same timing. If you want to trace something which is spanning multiple nodes, then you need to synchronize clocks, which in many cases we do anyway. Now, the timestamps are added to be able to merge the event and to order ordering between two independent streams. But we also get something else from them. It's not something we waste because timestamps are useful by themselves. You could be able to judge how long an operation took. It's not going to be a performance quality timestamp, but if you see that some step taking crazy amount of time, then you should be suspicious. So the streams are merged post-processing based on timestamps. So you work on multiple streams, every core got a stream, and you do it based on timestamps. So you have multiple pointers, and when you advance in all of them in parallel. Should not impact normal execution. When the application is running without trace, without collecting trace, we should have minimal impact. Trace code should never be inlined. It should always be a jump outside the normal flow of execution. Usually people are using trace macro to prevent instruction cache pollution. So it looks something like this. You have this predict false. Every compiler got his own prediction parameters. So you tell them, I'm predicting that tracing is inactive, is not active, because on customer boxes, tracing are not going to be active. And I'm saying, but I'm predicting it's not active, but if it's active, then you could jump somewhere else and then execute the function. That way the compiler will optimize the code and it won't affect production code because everything is outside. There's a branch false, which the computer can execute in parallel. And if this thing happens, then it will jump outside the code. But the normal code is not affected by this. So this contradicts bad code would look something like this. If trace level is bigger than some level, then run by code. So here you are forcing the CPU to take a branch, and by default, when you're predicting, you're asking for something to happen, it's predicted as true. And if the code is inside, then even if you don't execute it, it's already loaded as part of the instruction cache. So it's going to pollute your cache instruction, and it's pretty bad. I'm going to make a short stop here, and I want to show what actually I'm aiming for. So I'm going to jump to the end. So that's actually what I'm looking for. When people think of event trace, I think the event trace that we got in Ceph, in many, and also in many systems, it's not really event trace. It's a combination of few things. In some cases, it's just it's a system logger. So you could see system is starting up, everybody join. Oh, somebody disconnect. A network link is being brought up. The link is down. These kind of events, they are just logging based. It's not something suitable to high performance. My example is Wireshark, which is everybody here familiar with Wireshark? Wireshark? Anybody else know this product?
Sure, of course.
Yep.
I don't see you guys, but is this something people know? Should I explain? What is Wireshark? Wireshark is a network analyzer. It can capture, actually it captures packets going on the network, and then later it can display them and help you to find some problem with your protocol. Similar product exists for many years. Protocol analyzer, you can have Finisar used to be the market leader for this. They got Finisar analyzers, and which you use to connect physical lines and see when you develop a network card, what is wrong with your cards. So when you're thinking about gig-E and 100 gig-E kind of links, so there's crazy amount of information to collect. And Wireshark would never be able to collect it if every packet passing in the network would be stringified and dumped into some crazy thing by some kind of levels. So to be able to collect this huge amount of information, Wireshark have lots of filter. When you play with Wireshark, you can define what you want to collect. You can tell them, okay, I want you to collect IPv6 only, coming only from this Ethernet address and going to this IP address, and maybe I can say I only want to see RDMA over TCP. So you can define what protocol you want, you can define what peers, and you can also define what kind, like the more you get inside, you have more and more filters. You can say, okay, so if it's iSCSI, I only interested in seeing read request. So you could, and maybe read request coming to this LBA. I didn't use Wireshark for this, but I'm assuming it could do that. Finisar was able to do that. So you need crazy amount of information, and it need to be able to filter by as many parameters as possible, or else the system will not going to keep up with this information. The data is always collected in binary format. Nobody is going to collect the data in text format. But still, after the data was collected in binary format, you could display it in a human readable format. There's actually a very nice GUI, very user friendly to see everything, and you can get inside and you can search and you can try to find, show me packets coming from here, show me packets with this kind of problems, show me packets with this kind of header, and so on and so forth. And of course, you could view and search and everything. So that's the example, or that's the model I'm trying to emulate here. I'm not trying to compete with SYSLOG. I'm not trying to emulate Jaeger, which is another tool to collect system log. With Jaegers and friends, you should be able to see that everybody is running, that the network state is stable or not stable. You could see that the device is up or down, or is the up and down, but you're not going to get a granularity needed to see every single IO. Okay, so next.
Hang on. Jaeger is a structured event tracer. It's not a logger.
Yeah, I know. When I'm saying logger, I'm saying like in my thinking of a logger.
I've heard your presentation. I'm saying Jaeger is much more like what you're describing than like SYSLOG.
I know, but still, there is no way Jaeger be able to collect millions of IOPS. Jaeger is not something like Wireshark. I'm looking for Wireshark model, not to the Jaeger model. Jaeger is good to know how the system behaves. You cannot get the granularity to watch every single IO. So that's the distinction I'm making between logging and tracing. Tracing should be able to show you every single operation in the system. And maybe I'm using the wrong name. It's a name I'm giving this. I'm just trying to say.
I did want to point out, though, that we probably do want to replace Jaeger. We probably don't want two mechanisms for this.
Sorry, that we do what?
We probably don't want two mechanisms for this, unless we have a good reason for it.
Sorry, I don't get you. Maybe the sound here isn't. I'm trying to increase the sound. Could you please repeat?
At the very least, we don't want two sets of source level annotations. We don't actually want both Jaeger tracing and what you are proposing.
In that case, I think Jaeger should go.
That's what I'm telling you. Yeah.
Yeah. Okay. I mean.
So this would be replacing Jaeger.
Yeah, but I'm more concerned about a debugger utility. The event tracing I'm talking about is something to debug your code. It's not something to show the customer or to take a snapshot of the system and say, I can see something looks suspicious here. I want to be able. The event tracer I'm talking about is a debugging tool for developers. It's not for system engineers. Jaeger could be used for system engineers just to see how the system behaves. But I'm not going to go deeper on Jaeger. So now I'm trying to explain how we can collect data in efficient binary tracing. So I'm familiar with 3 different modes. The simple one, you add event in a printf-like format. It's easy, it's simple. The event trace is a global function. So you say, I need event trace. You write a function which looks exactly like printf, variable format, and you do %d, %s, %c, everything. So the types are coming in a format string, and you just use it like you'd use printf in C. It's simple, it's easy, and doesn't take a long time to write it. You don't need to be some amazing engineer to be able to do it. Everybody should do it in day one. There's 0 training required here. Optimize mode, which I've seen used in the past. I don't know if people are still using this because it's extremely efficient, but it's not so comfortable to use. So what happened is this, you define an event and sub-event. So sorry, there's event type. So example, event type is going to be a pglog event, and subtype would be trimming. And then there is a central location where you have a JSON-like file, and you can say for event type logger, sorry, pglog with subtype trim, then you're going to see, and then here you could type what's going to be the parameters, what's going to be the names, and so on and so forth. So it's strong, very efficient, but it's not so comfortable. Later I'll try to show some example, but the idea is you would write some text description for this, and it would be indexed by event and sub-event. And you'd give a list of parameters, and for each one you would say what's the type, so it know how much it have to read, and what's the logical name. So later you'll be able to search. So for example, you could say, in this event, I'm first going to have the OSD number, which is 4 bytes, and the name for search would be OSD. Then I'm going to have onNode ID, which is another 4 bytes, and you would search by onNode. Then I'm going to have timestamp, which is 8 bytes, and you would call timestamp, and so on and so forth. So by creating this file, it post-processing, when they reach to this event, they know exactly how to display it without paying any overhead, because they're just going to dump the data, which is going to be prefixed by the event type and subtype, and then they'll jump to this table. So it's extremely efficient, but it's not crazy uncomfortable. I've been working like this for many years, but I can say that in many cases you would see people being lazy and not adding event, because for every time they want to add event, they need to open this crazy JSON document and add the appropriate line. And then you also need to develop some utilities to make sure that everything matches. So if you're passing 5 parameters, the JSON file have 5 parameters, and you also try to do some kind of sanity checking of them. So it's extremely efficient, not the easiest to write. Now there's something else which probably you need to do either way, is if you have big object. So say you have object node, and you want in some cases to dump the full object node, or something for event for object node. So you're not going to write a crazy long line saying printf in print that. You need the tracer to be able to dump the object node. So you're going to give it, it's going to be done in binary format, like a mem copy or mem dump, or something similar to what we do when you write it to the disk, right? So there's marshal and demarshal, but it has to be efficient. And later, in post-processing, they will come and they will see that this is object of this type, and then they will call this function, which could be just O-string operator or something like this. So this you define once for the object, and then once it's defined, you could just dump it every time you need it. And so how do you do it? So if you do the printf, you don't, sorry, the most expensive one is, of course, is the printf, because you need the whole string format. So the way to get it to be efficient is, the simplest one is every time you trace an event, you also trace with it the printf format, which is inefficient because you're going to repeat the same thing again and again. A solution I've seen is that you keep the instruction pointer and the file. So you can say in this object, this file object, in this instruction location, there's a printf format. And then in post-processing, they will jump there and find the format. So it's working, it's very easy, it's very efficient. But if the binary is changed, because maybe you change one line, you compile, it's not going to work. So it's working, it's fine, but there's some problem with this. Something else I discussed, I don't know if it was implemented, but I discussed it in the past in my previous job. I suggested doing that. I don't know if it was ever done, is to keep a single translation table per file. So the first time you see this format, you're going to create an entry with the format, and the index is going to be stored with the event. So the next time the hash table is you're going to do a hash search. The next time you see it, you're going to find that it already exists. So you're just going to store the index. The index is going to be probably 2 bytes should suffice. I don't expect to see more than 64K event traces per type. Remember, it should be index per type. So you create a table which could be stored in a separate file because the event is just moving forward, and this one is probably kept in memory, and in the end you dump this whole table at once. It's not being dumped with everything else. It's something which actually should go to the header. So you keep a translation table from the format to an index, and then you just store the index of every event. I mean, the event could be in the trace thousands of times. Actually, I've seen it like hundreds of thousands of times if the event is a very common one. Say the event is every time you get an IO request. You don't want this thing stored again and again. You store it only once, and you keep the index. And then on post-processing, you see the index, and then you jump to the translation table. And of course, when you do post-processing, you load all translation table to memory. So that's how you do the printf. So that's allow you to do a printf-like comfortable event tracing, but still be very efficient in the way you store things. Then you need a way to do an online filtering of event collection. The common way to do this is to define a bitmap. So say you decide that you're going to have a 1K event type. It's crazy. It's a lot, 1K. I've never seen something go so big. But say that you decided you want 1K event type. So you define a bitmap. and every bit represents one event. So you could start with an empty bitmap, or you could start with a default event map, or you could create event type for every group, or for some kind of IO flow, like for Blue Store, I'm probably going to use this bit set. And then from this thing, you could create, modify, and you could do it online. The bits should just be set, and you should have an easy API for this. You don't want people to manipulate bits. You should tell them, I want you to add event for pglog, for scrubbing, for TCP, and for Blue Store. You should use human readable commands. Don't let customers or users manipulate bits. And how this thing is working. Every event trace call is starting with two parameters, event type and subtype. When you do trace collection, we need to filter out an event. The way to do this is, what is this? No, okay, I didn't talk about it. I talked about this. Okay. Every time we call the event, we put event type and subtype. When you collect event, we need to check always. When you do online collection, right, the machine is always running. If the event tracing is active, then you jump outside and you start to look. And so this was event type like this. Then you check the bitmap. If the bit is set, then you're going to collect the event. If not, then you skip it. And this thing you could do online and you could change online. That's one of the biggest flexibilities with this model. When you do event tracing based on severity from level 0 to level 20, and the event type you're looking for happens to be in level 20, by opening this, you open everything and you get a flag. Here you could just decide which event type are interesting for you. And it might be, as I said, it might be Scrubber, the least interesting event, but if Ronen is debugging his code, for him is the most interesting thing. So he's going to say, I just want to collect Scrubber event. I don't care about anything else. So just collect that one. So in runtime, the event filters will be done by looking at this bitmap. And other things, actually, I should have used probably another slide. The last two bullets. You should also allow collecting by subsystem. For example, when you're running Ceph, you could say, okay, collect OSD events. And then I'm going to tell you what else, but I just need OSD, or just Blue Store, or just RocksDB, or whatever. And then you can also limit event collection based on object type. Just collect event if they belong to this PG group. I don't care about other PG groups. I just want this one. You need a way to view and search the trace. So you need some way to look, to view the trace forward and backwards, just like how you would search a file. If you're reading a page, you should be able to go up and down. You should see reverse and forward tracing. The renderer should have current location. So you should always be able to say, okay, I've seen up to here, now show me the next page. It's a paging concept, not like a paging page, but you can see one page after another, and it always knows where it is. You can say, now scroll up, scroll down from the current location. You don't need to each time repeat, like I've seen people do. You grab for something, and then you say, from this point, you filter, and then you do it. It's complicated. Just remember where you are. And then you can say search for the next event. You can give it current location. Usually there are free macros. There's head, tail, and current. So you could search from the beginning until you see something, from the end search backwards until you meet something, or from here I want you to search forward and backward until you see something. When you view the event, you could do second filtering. Because when you collected, you filter stuff, but when you view it, you say, okay, we collected a lot of information because I didn't do the event tracing, somebody else did it. But I'm only interested in this event, so just show me them. I don't want to see everything else. So you can give it like, show me only this or show me everything except this. Show me the next object, the next appearance of an object. Show me the next, I'm looking now for object node. Show me the next time I can see the object node. Or show me the next time object node have this value. Show me the next time the object node ID is this one, or it's within this range. I want go to the next time, but I want to see only object node between X and Y. And of course, you can do a combination in a logical file. I want to see event type 1 or type 2 when variable 1 is equal to x1 and variable 2 or variable 1 is bigger than x2 and so on and so forth. You should be able to apply this kind of logic calculation. How you do this? So how can you do the filtering? How you actually implement it? So the first thing to do is every trace event is started by event type and subtype. The event code is always dumping them in binary format as the first thing for every event record. It could be 2 bytes for the event type and 2 bytes for the subtype, or maybe 1 for each, depends how many events you want to create. The renderer always knows that the first 2 parameters, 2 bytes here and 2 bytes here, what does it mean? So when it's going, it's just reading the first 2 bytes of every event record, and then it can skip them at runtime. So it's location-based. The way for the event trace renderer to understand what it's doing is based on the location. Always the first object, the first bytes are going to be event type and subtype. You could use the same concept with more information. So let's say that OSD, always when we collect event, we need some common parameters. We always need a pool ID, the object node ID, and so on and so forth. So you could create a macro or function, and you can call it OSD tracer, and that macro is going to ask you to insert pool ID, object node ID, and so on and so forth. And this thing will pack all this information and dump them in a single well-known location. So they always know that the pool ID is the next 4 bytes, and object node ID is the 4 bytes afterwards. So that's similar to what I explained before, that you can create a JSON format to describe it. But here it's actually useful, and that's this thing I've seen more used more commonly than the previous one, because you can create a family of event tracer. And this family could be like in the beginning of every project, the project manager, project lead is going to define the common macros for his project, and they're going to have like 3 or 4 JSON line explaining how the event is going to look like. So, and usually it's going to say like the beginning is going to look like this, event type, subtype, which is of course, then they're going to be pool ID, object node ID, block ID, and so on. And after this, they're going to be something else. The something else, it's like before, print a format, which you could render on time. So it's very beneficial if you do it with common types, but you're not going to be able to use it for every single parameters. So usually what people do is description based. So for every parameters, you could start and say, now collect LBA, column, and then you give value. So you attach, before every parameters, or every parameters that you want to give a name, you start it by giving a name to this. Can you see my Emacs? Do you guys see my Emacs?
Yes. Yes.
Okay. So.
Yep.
So that's an example of how you could use it. So you do event trace, and of course you start by say that's pglog event. You're always going to start with the event type and the subtype. Then I'm going to use here the formatting, and it's going to be, this event is a trimming log, and then I'm adding some parameters. Now the parameters, this is not printf. It looks like printf, but of course it's not printf. So every parameter could be a tuple. Doesn't have to, but could be. So you do it like this. I'm going to give you a value, and that's going to be the name. So if you're going to search, you're going to search for onode, and that's the value. And the value is 4-byte unsigned integer. Then the second one is going to be pool. So that's the name you're going to look by it, and that's how you store it. And actually, in some cases, you could actually skip this thing. Actually, no, because you need to know that they're going to be here. So you don't need to describe the parameters, but okay. And the last one, you're going to say it's a character, and here you don't give it a name. It's not interested. Maybe it's some information you want, but you're not going to search by this. You're only going to keep this kind of information for something you're going to search by this. So back to this. So that's for every parameters you want, you could add a type, but there's going to be, of course, unlimited number of types because you don't want to type everything in the world. Not everything going to have a type. It's crazy. And the way you do it in the beginning of the event records, there's going to be a header, and the header is going to have all the event types. So it starts by the event type and subtype. You don't need anything before them. You know that they're always going to be there. And then you could put the address for the index of the format string, and then the parameters themselves. The parameters, they could be also, you could start them the way I showed, and then you could see, and again, it's going to be an index to the parameter type, and then the value, index type, and of course, everything going to be descriptive. This thing, it's similar to the JSON thing I described before, but it's done automatically on the fly by the event tracing code. The JSON thing, when I was using this, it was not very comfortable. People just don't like the idea of writing the code here and then jumping to another file and writing something. When you do this kind of code, it's much more intuitive. And it's easy, it's not complicated. You just do it and it's good. Other thing I'm saying is that the types, of course, going to be enumerated because the type name could be long. You could say maybe the type is onode ID, but you're just going to keep a 2-byte index into some transaction table. And then some other features I've seen in event traces, not the one I was working on, but I've seen on more advanced one, is that they are also type aware to the code. So whenever you use something which is enumeration, they're going to, when they display the value, they're going to detect the enumeration name. So if you enumerate all kind of operation and you got so get, put, delete, whatever, and the index, it's actually an index, but they're going to use the enumeration name. And other things are even more interesting when they can see that you're using something of some type is going to create on the fly the type later to be able to search by this. And I'm talking about like if there's going to be type like onode ID type, so you wouldn't need to have this onode, then onode. You're just going to get from there. And that's all. And I was able to do it in less than 1 hour. I'm going to stop sharing. Question?
I have a few comments.
Okay.
If okay. I lost your. You're there, yes? You're still there?
Yeah, I'm here. The network is slow, so I can hear you, but I see you.
Okay. One comment that I think might be a good idea to follow is that we should strive to create the output either when collecting or immediately on the spot in another process, in a format or in another process, in one of the formats that there are already existing tools for. You talked about Wireshark. There is, for example, kernel shark, and there is trace compass, for example. All these are tools that read trace compass, especially tools that are already there, and they can read many formats of trace records, and all the functionality that we might want there is usually there: sorting, graphing, filtering, whatever. And so it might be a good idea to create a format that is known for tracing. That's I think the most important comment. And another one is that I would suggest, I think we mentioned that, a feature that I had in the tracer I used in my previous job, which was of temporary streams. Suppose I'm now trying to trace a bug. I know that it happens during the operation on a specific object. Suppose I'm collecting a lot of information for each incoming request. But once the request is finished successfully, I don't really need all that information that was collected. So what I can do is mark part of that information as transient. And if everything went right, in specific time points, I can just throw it off altogether. Maybe remaining with only the basic, what we would call level 1 or level 10 trace data. So this is one feature that...
Ronen,
That's
I'm
features,
familiar
though. I don't think it's all that
concept.
general.
Sorry, I don't...
Sorry, there's a similar concept I'm familiar with, which actually I forgot to put in my presentation, which is the event to stop the tracing. So usually tracing, they're using a cyclic buffer, so everything is going to overwrite each other. But there is there's a showstopper. You need to define when something happened, then I want you to stop the event trace, because otherwise you would collect forever. So you can for example, when you see that object node, or when this sanity check is going to break, then stop the event trace.
This is one option. I'm not sure it's the only one.
I don't think that's really what Ronan is describing.
Sorry?
I don't think that's what Ronan is describing.
No, but it solves a similar problem. It does, because if you have limited space and you know that if something happened at a specific time point, everything that was collected a few minutes ago is no longer there because you just overwrote it.
No, hang on. So, Gabby, I had a couple of practical questions about what logging means here. Is the goal here, okay, so let's say that we're collecting logs from a customer and we have it set up so that the rate of generation is about 20 megabytes per minute or so. That's a lot, but it's not impractical at all to keep weeks of that.
20 megabytes what?
Per minute. So we can sustain
per minute, okay.
Yeah, we can sustain that rate of write for a long time.
Yes.
Right.
It's actually nothing.
I understand that, Gabby. I'm just asking. Okay. So my question is the idea is to write these to a file and roll the file, right? The idea isn't to roll a circular buffer. In the middle, after the thread generates the event, but before it's written to disk, yes, it's in a circular buffer. But as long as the write-out process keeps up with the generation, it's not a problem. Is that the idea?
Yeah. So there are two things. Before we get here, there's one critical thing to understand. When you trace into memory, performance going to suck. But when you trace into file, performance is going to be extremely slow. So usually when you try to debug distributed system, you aim to get as much as possible inside your memory. So that's why you do all this crazy filtering. when you put stuff in file, yeah, sure, you could keep it. When I was talking about cyclic buffer, I was talking about memory cyclic buffer.
I know. And when I said 20 megabytes per second, I didn't mean all of the events that are generated by the system. I meant the ones that were configured by the developer to catch the specific bug
Yeah,
they
sure,
were
sure.
looking into.
It's
So
actually going
this
to
is
be
not
extremely
random bullshit. This is what the developer thought they needed. Right?
Yeah.
Yes,
So
but
the related question is, suppose the amount being collected is larger, and we actually can't keep up with writing to disk. There are sorts of logging where the right answer would be to drop some events, and there are some kinds of logging where the right answer would be to slow the system down. Have you considered a way to distinguish between those two sorts of events?
No, I did not. I've seen your question, and I don't know how to answer this because
It's complicated,
it
yes.
must be possible to do it. Yeah, it's
Now,
very
it's not
complicated.
nearly as difficult. So
And
Ceph has
actually,
a pretty clear
the solution
demarcation
I'm
between these
familiar
sorts
with,
of events, to be honest.
I'm just saying that the solution I'm familiar with is that you never slow down the system.
Yeah,
So
that won't be
in
acceptable.
the work, they will be just dropping. It's the same way
No.
the fabric behaves, right?
That won't be
When you
acceptable.
can't keep up, you drop things. I know. And then you'd
Yeah.
see actually in the event trace, you'd see the tracer would show you that there's a holes. And
I know.
sometimes you would get a event trace and you say, oh, there's a hole here.
Yes, I
Might
guess
be
all of that.
still, you know.
So my
So
question
you
is
could say what
not
should be
why do things usually drop events? I understand that part. I'm saying that there are a few events in the OSD where if we didn't have the ability to reason from absence, it would be a problem.
yes.
So it would be, and these tend not to be high volume events anyway. So I don't actually expect it to be a problem, but there's a difference between it usually won't be dropped and never will be. So I was wondering if you'd given that any thought.
Okay, so what you say, there is some
PG state transition events are incredibly important, and they can cause a full cluster to simply cease functioning.
Okay. So
and under those conditions, it's utterly critical for developers to be able to turn on these log lines and see all of the events. Is that the idea? Why do a separate file? Why is that the important part?
Because the way the event tracer is working, right? Like everything, all the event trace is collecting is written into a single buffer and then dumped into disk.
Yep.
If there's one event type which is critical and it might be happening just once a second while others are happening every microsecond, you cannot hold the whole thing.
That seems like a multiple buffer problem, not a multiple file problem.
Yeah, I said multiple buffers.
You said multiple files. Okay, that makes sense.
Sorry, I meant multiple memory buffers.
Yes, I agree.
Yeah, the disk itself, yeah, sure, no problem. I've never seen this implementation, but of course you could do it. I mean, there's like...
Yes, I'm simply raising this as a use case, that's all.
Yeah, I'm sure. People come with a lot more of interesting ideas. I spoke last week with this guy, Tom, about his event tracer. And he said, yeah, I've done it 8 years ago, but since then I've done it for many other systems. And each time we do it, it's become better. And he said, now the best one I know is the guys in Invest Data because, you know, they start with everything he got and then they added more. So there's
this isn't that kind of feature. This is just a thing we use all the time.
Okay.
Now. So, yeah. What I'm saying is you've characterized the PG log or the Ceph log a bit inaccurately. Some of the tricks that are present here are already present in the OSD log, and we do use it to capture all of the operations of a certain type pretty frequently. Now, it's incredibly non-granular. You have to use grep to search it, and it's a giant pain in the ass. It's also inefficient for all of the reasons you've outlined. But we use it for these things anyway. So we need to be able to use this system to do those things too.
Yeah, sure. Actually, I've done it using that system.
Excellent.
And
so you know what I mean.
Yes, I know.
I also wanted to
about keeping the position. Before I start using this system, I didn't even realize that I'm taking for granted that the logger know where I am.
Yeah, I wanted to talk about that too. So while a highly featureful log viewer would be great, I think the first step probably shouldn't be that. It should be a utility that just processes the binary trace with a set of filters into a text file. And my reasoning for that is that a log viewer is a great example of a place where you can generate kind of an unbounded set of features. And one way or another, we will need a way to process a trace with time and other event filters into a text file, simply so that it can be compatible with other tooling. So I suggest we develop that part first. It's annoying, admittedly, that it won't have the features you outlined. Those do seem good.
Well, actually, you can also develop something which takes binary and then dump it into text.
That's what I'm saying should be the first step.
Oh, sorry, I didn't. Sorry, the
Yeah.
line keeps disconnecting, so I'm just
That's
hearing
fine.
half of what you said.
What I mean is the utility that embeds those filters and time bounds into just a command line utility that emits a text file, I think should be the first step.
Yeah, but I think it happens by default. When you have this renderer, what it does is
the renderer is massively more work. That's what I'm saying.
One second, I repeat what I suggested earlier. It's very easy to, if you are dumping everything into a text file, it's very easy to dump it in a format. Usually it's a JSON format that is, you can feed to one of the
Ronan, I want it to be readable by less, not in JSON. Thanks. I want it to look like the log lines that show up. I want it to be readable in less. I want it to be greppable, and I want to be able to do all of the usual Unix utility stuff to it. So no, I don't really want it dumped to an intermediate format.
I think that could be a second step, though, right? We could be dumping to a format understood by existing trace viewers like Trace Compass.
But that's not what I'm talking about here.
Right.
I'm talking about instead of the log viewer, just the actual tool used to look at the logs. I think the first step should be something that simply renders it into text in a file on disk. Yeah. With all of the relevant filters built in as command line flags.
I think when you write a renderer, that's how it works. So it creates a text, and the text could be displayed on screen on some nice GUI, or it could be just be dump as a file.
Okay.
It's just open things on the fly.
So the other thing I wanted to ask about is the Ceph context pointer that's passed around. There's a reason for that. It's not for funsies. Everywhere in the existing daemons, there is a global Ceph context, and you don't need to pass it around. The exception would be any code that interacts with library code, because in those cases, there could be multiple libraries within the same process with different config parameters.
I don't know, I've
so you should keep that in mind. Yeah, it's in the PG log code because there are utilities that interact with that code. In principle, though, if those were only ever called from the daemon, yeah, we could use the globals. Okay. It's a little complicated, but that's why. I'm not saying that it's not ergonomic. I just wanted to bring that up as a thing.
Okay, maybe I was just unlucky to get into this code, but my feeling was that when I was I needed to start changing the code everywhere.
It's just that depending on exactly what's going on, it may be important for your logging design to handle the case that it needs multiple instances of itself within the same process. That might matter. That is all I'm pointing out. Okay, that was all my questions. I'm done.
Okay, and the last thing I forgot to mention, I'm maybe pushing people to consider an existing event trace solution, which does everything I explained. But there's one problem with it, actually. It's a big problem that it's not supported. It's something which was made open code 8 years ago, and it was never touched since. I spoke to the guy, and he said he thinks like 1 or 2 weeks time, and it will be working again. Still long compatibility and libraries version changing and so on. So I don't know if he means 1 or 2 weeks of his time, which when he's familiar with the code, or 1 or 2 weeks of anybody's time. But there is a solution which I know it's very similar to the stuff I was describing. So I don't think we should be writing everything from scratch.
That does seem better.
So, Gabby, a quick question. So why was that solution not used for like 8 years or something? Is it that the developer just didn't get to finishing it up, or were there other issues?
No. This solution was developed for Infinidat. Infinidat is the third company made by the same guy which made Symmetrics. And every company he started, he was recreating the event trace and refactoring what he knew. So the first one was made 30 years ago, which probably the one I'm familiar with, and that's the third iteration, was done 10 years ago. And the guy which wrote it for him insisted on making it an open source. So 8 years ago, it used to work, and it was their solution. And since then, libraries change, paired version change, CLang version change, and so on and so forth. So it's not that it used to work, it was not updated to support, to build with latest kernels and stuff like this.
Got it.
By the way, he also mentioned he's going to speak with his friend in Vest Data, which apparently got the latest iteration of this design, and try to convince them to make their tracer open code. I don't know if he's going to succeed, but if that would happen, then it will be getting the best of the trade.
Yes, yeah, I mean, to just sum it up, sounds like we're kind of on board with your ideas, and the next step would be to just create a small prototype with some isolated piece of Ceph. Would you agree?
Actually, I would stay away from creating a prototype. If we could get his project, and again, it used to work 8 years
prototype
ago.
with that project.
With
Prototype
I mean,
using that
using-
project.
Yeah.
Oh, sorry. Yeah, sure.
Using whatever design it is you think is the best way to do it.
So I think his project was more advanced than the stuff I was describing, because it was just another refactoring of the stuff I'm familiar with. And I don't know exactly what is stopping it from being functioning. I think it's just a matter of building this with the correct tools, but I don't know.
Right.
And
So
he said
learning
he's
that
going
would be
to be able to help, but I don't know if he meant, he said he could have, if you have question, come to me, but I don't know how much he meant to invest in this. But he did make an effort to make it an open source 8 years ago. So I think if Red Hat would make it to be, or even us, we made it to be like an official tool, that would be good for him, because he likes the idea of open source people using it.
Right. So the goal of a prototype would be to find out exactly what needs to be done.
Yes.
Cool.
I wanted to go back slightly to the idea of the Jaeger tracing as well. I think that's kind of a separate use case, and I'm not certain whether it would be fully captured by the same kind of mechanism. As the use case with Jaeger involves hierarchical spans. You're kind of passing the span ID along everywhere.
I think the high performance one is not going to synchronize. It's not built to synchronize with thousands of machines.
That's not how Jaeger works.
Okay, so how Jaeger is working?
The way Jaeger works is it's just a bunch of different independent processes generating events. They're later aggregated based on a couple of well-known IDs that are generated in a deterministic fashion. The generation part's not functionally different from what you were describing. The only difference is that you send them with some degree of rapidity to an aggregator. It would be a matter of adding a filtering mechanism to your thing so that in addition to writing things to disk, some events with appropriate tagging also get sent to the Jaeger aggregator.
Right.
Which seems like a good idea to me. But I understand if we don't want to do that immediately, or if we simply want to leave that under Jaeger. But I disagree that they're different use cases. The addition of a span ID or a client ID thing will be interesting in both. The specific span ID may or may not be interesting in the on-disk log, but I suspect that it won't be detrimental and that the rest of the event will be interesting. In fact, I suspect that absolutely every trace event that would be useful for Jaeger would have an event right next to it for emitting to this log. This is why I am arguing that it would be ideal if they were not separate systems. I cannot think of a thing I would want to emit to Jaeger that I wouldn't also want in the disk trace.
Yeah, I agree. It
Okay.
would probably be a strict subset, but it might be it's kind of I wouldn't say it would be unnecessary for like the minimal start here. It might be like a later step to incorporate the Jaeger aspect into this system as well.
Yes, I'm on board. Well, if by the Jaeger aspect you mean the ability to pick out events and send them over UDP in a format
Exactly.
that Jaeger endpoints are appropriately dealing with, yes, I agree
That's
with
what I
that
mean.
part.
Yeah.
But I want the original source level annotations to have this in mind. That's all.
Yeah, I
Remember,
think
we
that
have
makes
to go
sense.
through and annotate a great deal of source code. I don't really care about adding more functionality to the back end of the logger, but rewriting the source annotations is a lot of work. So if possible, and a little bit of forethought avoids that, then it's worth it.
Yeah, I agreed. Okay. Anything else on this topic? Should we try going back to Version now? Do you think your screen sharing or connection is working better?
So we'll be looking into how to deploy an NFS Ganesha gateway cluster using Volumes plugin. Before that, let's look into the other ways in which we can deploy one. So there is Rooks. We can deploy one using Rook, and mostly in Rook, everything is done with CRD. So first, for deploying an NFS Ganesha cluster, we'll have to deploy the Ceph cluster using the CRD, and then even create a file system using the CRD, and then NFS Ganesha daemons are created using a CRD. But this does not provide an interface to manage the exports. For creating an export, you will have to pre-populate the config objects in the specified pool and namespace. If you look into the NFS CRD, there you can see there's a cluster name, and then as well as there is a pool name specified and the namespace. Then the other way is with Ceph ADM. Ceph ADM uses the Ceph org apply command, which deploys the Ganesha daemons. But again, it does not provide an interface to manage the exports or the config. In both Rook and Ceph ADM, the Ganesha daemons are deployed with a minimal config, but they do not manipulate the exports. Again, here, a export config object needs to be created. Then the other way is with dashboard. So with the dashboard, the thing is we need the NFS Ganesha clusters already deployed. It does allow us to manipulate the exports, but it also requires setting up a Rados option, like pool and namespace setting of dashboard before the exports can be created. Next, let's look into the way we can create the NFS. We can deploy the NFS cluster using the Volumes plugin. So as you can see here, this is so with the NFS Volumes plugin, we can create the cluster as well as we can manipulate the exports. The cluster creation is very simple. It requires the cluster type and the cluster ID to be specified. And let's look into the code for this. So in other deployment ways, actually you need to also create a pool before an NFS cluster could be deployed. But with the Volumes plugin, we create a pool for the user, and all the Ganesha daemons share a single pool. All the NFS clusters actually share a single pool, but a cluster is separated by the namespace. So the namespace is the cluster ID basically, and currently RGW exports are not supported. So we are just looking into CephFS exports. And here we also create a config object, which will have a URL to the export object for the user. This does the basic checking and let's show the, and with deleting the cluster, again requires just like a single cluster ID to be passed, and this deletes all the created exports. Another differentiating factor is that we provide cluster information, which is not provided in Ceph ADM or Rook or dashboard. And for creating an export, we ask the user to specify the cluster ID, FS pseudo path, and then the path and the CephFS. All these things, like bare minimum things to be specified for creating an export. But along with that, we also provide a way in which user can create their own export with the user config object. With this option, they can also modify the Ganesha configuration. So Ganesha actually commits the last red config block. So if a user creates a user specifies their own configuration, it takes the precedence over the default one, and this can also be easily removed. And for a single cluster, we restrict to a single user config object. Let's look into export creation. So we ask very little things from the user, like cluster ID, pseudopath, if they want it to be read-only, and the path and the FS name. And we define the other parameters required. And currently the export created cannot be modified. So that's kind of a future work which we're looking into. So when we create an export for the first time, actually we create an export dictionary which has the cluster ID as the key, and the values are the list of export objects. And in a case, if the manager is restarted, then we read all the export from the Rados pool with this particular method. But this does not happen every time. This only happens when the manager is restarted or the first time the export is created. Otherwise, this method is not called. And along with export creation, we also create the user for every export. And so we create a user with the following caps. And this is also removed when we delete an export. And this also gets removed when we delete a cluster. So basically, when we delete a cluster, all the exports gets deleted. And along with that, the pool objects are also deleted, but the pool is not deleted. And we have the tests and the NFS test needs to be run with the Rados suite. Basically, we are testing this in Tutorology with Ceph ADM. So we test mostly all the commands. Like test org CLI needs to be passed in as a filter for testing this out. That's it. So getting it started, in vstart, with vstart, we can deploy an NFS Ganesha cluster in two ways. One is with Ceph ADM, and the other is without Ceph ADM, using the test orchestrator. So here basically we define all the required Ganesha config blocks and the default values manually. And also set up the Ganesha Rados. We also populate the Ganesha Rados Grace database. But here you cannot manipulate with the export objects. If we create the cluster using test orchestrator, let's look in how to create one. I usually do it with Ceph ADM. So here we already have a command to create a cluster and create an export. This is from here. If Ceph ADM is chosen, it creates a cluster, and then it also creates an export. So we have created an export with sudo path as ceph-fs, and fs name is a, and path is root path, cluster is vstart and all. We can check this in the Rados pool. If the export object is created, so the following export block is created. So what if we also create a user config object? So I have a config with these values. We can create one with the config set option. This gets created. You can verify it in the Rados pool. And we can also check the user conf object. So this has the export block which we created. Now let's mount and see. So with the vstart, we also display the information, what is support used and the IP and all. Here it's Ceph. That's something. And as you can see, get written successfully. And what if I want to go back to the default configuration, I just have to do the reset with cluster ID passed. This deletes the user config object. You can see there is no user config object present. And one more thing. So we have this conf NFS Ganesha restart object. This has the Rados URL to the export object. Basically, in both Ceph ADM and Rook, this particular object is created, if not created by the user. And we can also, with the export, you can get a detailed view of the export block without looking into the pool, Rados pool. also see the user created. So this particular user is created by Ceph ADM, and the other one, this one, is created for export by the volumes module. And if I delete and if you delete the cluster, everything gets deleted. You can again check and verify. Same goes with the Rados object. Check there. So yes. But there are issues with the current deployment. So one is the integration of dashboard with the volumes module. So in the currently, the exports created by dashboard cannot be detected by the volumes module and vice versa. Similarly, there are some couple of things which are different in dashboard and which is different in the volumes module. But in the future, we want the dashboard to use the volumes module to create the export. Both of them use almost the same, create the export in a similar way, but the options provided is little different. We have covered the discussion in this particular tracker ticket. You can have a look. And second is the compatibility with Rook. So currently the Rook module in Ceph is in a very bad shape. Most of the commands are not working. That needs to be fixed. Also, we are looking into the volumes module is compatible with Ceph ADM. We also want it to be compatible with Rook, and there are no tests for Rook in Tutology. We're also looking into adding a test in Tutology for Rook. And there are some features which are missing on the volume side. For example, one is the RGW support. And this is a big difference between the dashboard and the volumes module. Dashboard supports the RGW exports, but the volumes module doesn't. So that needs to be done. And second is, as I said, you cannot modify the export object created. So we also want to work in that. Yeah, that's it. Any questions? Am I audible?
Yeah, that was great, Parsha. Thanks for walking us through that, and it's good to see it in action as well. I was curious, you mentioned about the idea of adding Rook tests to Tutology as well. Do you have an idea of how that would work?
Yes, currently, I tested it out manually on one of the Smithy machines. The manual script on using Minikube, basically. That is working fine, but we need a local registry for Ceph images instead of depending on QA. So that needs to be done. And there are a couple of other things that needs to be figured out how we want to do it. But we want to have an option in Tutology that you can either test with Rook or Ceph ADM. And most of the other tests should be like a generic template, which will go with either of the orchestrator backend. Yeah, that's it.
That sounds great, and it would be very useful for many other features, I imagine, too.
Any other questions?
I just want to add there's currently discussion on the developer mailing list concerning the state of the Rook Manager plugin. So anyone who wants to chime in on that thread would be welcome.
Thanks, Patrick. I haven't caught up on that myself. Thanks for adding the dev mailing list as well as the kernel one too. Okay, sounds like that's it for that one. Then, so Scott, do you want to talk about ADNN?
Okay. So my name's Scott Peterson. I work for Intel. A couple of you know me. For those of you that don't, I previously worked on a persistent memory-based HA write-back cache for RBD, which took like 2 years longer than anyone expected it to. Still not quite done. So the latest thing we're doing is this thing we call adaptive distributed NVMe over fabrics namespaces, and that's a mouthful of a name because that's how naming works in the NVMe universe. And if you call it adaptive distributed namespaces, then Word keeps autocorrecting that acronym to AND. So we had to add another word in there. So this crowd understands the basic goal here. I just presented this at the Storage Developer Conference, and we all get in this universe that this picture on the right is how storage works in the cloud. Picture on the left is how NVMe over Fabrics is typically used. Basically, it's a really fast patch panel. You can connect a drive to a host. But that's not how people want to use their storage. So our basic problem statement here is, well, NVMe over Fabrics has a lot of features that people love, except for this patch panel, point-to-point type connectivity thing. And so we asked ourselves, what would we have to do to NVMe to be able to connect to anything? And it turns out it's all it takes is we add this this yellow box here. I don't know if you can see my pointer. You probably can't see my pointer. Can you see my pointer if I do it over here? I'm pointing at the yellow box in the top thing there.
It's a little delayed, but yeah.
Okay. So the idea is that we take this point-to-point protocol, and in all the entities on the fabric, we add one component called a redirector. And its job is to examine every I/O, look at the start LBA for it, and instead of sending it to the target, it chooses one of the targets based on a table of hints that it has accumulated from these places. So the basic idea is that they can, what this diagram is doing is walking you through the sequence of two I/Os. And in the first one, the blue one, this host sends it to what we're calling here the wrong place. We're saying that the first I/O number 1 should have gone over here to storage node 2. And so the host doesn't know that yet. It sends the I/O to this storage node. Storage node knows that it should be over here, so it sends it there, tells the host, hey, next time, send it there. And then subsequently the host does that. This is the basic idea that a host could learn from making mistakes. In practice, as we'll see towards the end here, it turns out this system actually, the way it worked out, they tend to learn it all when they connect. So, and this learning in response to IOs, although we still like this idea, turns out to be harder than you'd think in the environments that we want to run this thing in. So, why are we talking about this for Ceph? Well, because I'm kind of blasting through this, let's go through this brand new slide here, which is just to summarize. Our whole idea is we're now going to connect hosts instead of to one thing. We're going to connect them to many things. If you're making a distributed storage system across many nodes, then there's going to be targets, NVMe Fabrics targets, and all of those nodes, and your hosts are going to connect to all of them. You will then, as the architect of that storage system, arrange what it says here, to basically let your storage system complete any of these IOs no matter where they arrive. And then you will try to make that not happen. That's the basic idea, is you can handle anything, and then you try to get your host to be smart enough to send it to the right place so that you can avoid that second fabric hop associated with a gateway. So I don't know how much time we actually have here, so I'm trying to do this fast and also skip over the things that Ceph people already understand. So if there's anything unclear about this, go ahead, raise your hand, tell me to go back to the previous slide. That's fine. I'm expecting that none of this is new to most of you, except these terms here. So again, we showed the little box, the redirector box. That's a little thing in the IO path in the hosts, and we also put it in the targets, and it's the same box. We use the same logic everywhere. Those things use this concept of location hints, where the things next to storage, the redirectors next to storage that are informed by some cluster manager. In Ceph's case, it's actually a lot simpler. Where things are enabled to communicate that to hosts in a standard or abstract way. Now, the hosts don't have to have any specific knowledge of the backend. They just look at those hints and they do what they say. And then we introduced this term called the distributed volume manager, which is that boundary for all that closely coupled stuff in a storage cluster. And so this is the details of a redirector, but I think we've covered most of this. So the distributed volume manager is the thing basically that decides where things are placed and how it will communicate that to hosts. Now, the whole ADNN idea covers more than just Ceph. So we've defined a few. We expect that there could be many types of location hints, but obviously in order for these things to communicate, you have to establish some that they all understand. And so we're working to come up with an initial set that probably works for most cases. The idea is that this will be extensible. So a storage system may send a hint, an old client may not understand that hint, and it will just ignore it. But we hope to enable jumpstart this with a set of a few that probably work in most cases. And so they basically fall into the categories of simple, just says this range goes here, and a group you could call algorithmic, which is essentially a function. You say this range of LBAs has this function applied to it to select this target. The simplest of those is striping. We all know how striping works. So a striping function would say, here's a set of targets, here's an LBA range, here's the parameters for the stripe function. Run this function on that start LBA, look up the target, send it there. That's how striping would work. And the hash hint is what you use for Ceph, obviously. Now, our original idea is that this would work with other storage systems that use consistent hashing as their basis for placement. Chief among them was Gluster. Now, I had never used Gluster, but I did spend a lot of time working in Ceph, as some of you know. So it took me a while to get back around to Gluster and discover, fortunately, while it uses a hash function for placing files, when it does block, your whole block device is one file. So it doesn't actually spread it over bricks. Maybe somebody's got a patch for Gluster that lets it do that. But until Gluster shards its block devices over bricks, this hash hint isn't going to be much help there. But we did make it work with Ceph. So I thought I would be able to get through this much faster. I'm sorry I have to drag you through basically everything I said at SDC, but some of these concepts I kind of have to explain. So a host, an ADNN host, sees any storage system as a DVM, and they all have a common set of behaviors that lets these hosts be as dumb as we can get away with. The basic idea is that everything complicated is the DVM's problem, which sounds like we're creating a lot of work, but when you consider that lots of distributed storage systems already exist and they already work, they've already solved all of these problems, what we're really doing is just naming the important things that they all have to do and deciding how we're going to communicate that to hosts. Now, in the NVMe over Fabrics world, there's a thing that you can barely read, this box. Sorry, wrong screen. This box right here with a mouse wiggling over it is labeled Discovery Service. And this is how an NVMe over Fabrics host, in theory, can be told the address of a discovery service, and then it can ask that discovery service what subsystems exist on the fabric. And subsystem is what NVMe Fabrics calls targets. And it tells it the addresses and things. And if they have the right credentials, then they'll be able to connect to those things. So the idea is that an ADNN DVM will have one of those inside it. These hosts will be told about that discovery service. The discovery service will reveal all the nodes in that storage system, and they will then commence connecting to all of them. Once they connect to them, so in this little example here, you can see we chose, say that this hypothetical DVM has 4 nodes because that's an interesting number. It's greater than 2. The 2-node storage system, you think of it as having just HA or active passive, and we want to highlight that this is intended for slightly more complicated things. So see all these yellow boxes here. This represents a volume provisioned from these SSDs on all these 4 nodes. It's in some way a little bit more complicated than just mirroring. So let's consider that. Let's say this host is supposed to use this yellow volume here. This distributed volume manager will know that. It knows this host's identity, so it will let it connect in the first place. When it connects, it will tell it about this yellow volume on all of these targets. So this host will see it everywhere. Now this host has a redirector in it. So when it sees these yellow volumes and it notices that these yellow volumes are ADNN enabled, basically they have redirector features, then it basically lumps them all together as targets for its internal redirector. And at that point, this volume is available to it and it can commence sending IO to it. Now, it doesn't know where the extents are yet, theoretically. So what should happen next is these targets should all start informing it. So the owner of this extent should say, this extent is here. In fact, it can happen any way at all. All of these targets could tell it everything. It turns out that doesn't really take much data, so that's probably what will usually happen. And that even helps when, for instance, say there's some temporary fabric problem and this host can't connect to this server, but it could connect to the other 3. Now, they'll all tell it that this extent, it should send it here, but it doesn't have a path there, so it will send it somewhere else. Remember that a DVM is required to complete any IO that arrives anywhere inside it. So whichever one of these other guys gets the IO for this extent has to complete it by forwarding. So if you're building one of these things from scratch, that's one of the things you have to provide as a DVM architect. The beauty of if you're building a distributed volume manager adapter for Ceph, obviously that's a lot simpler because inside these things are all just sending it to RBD, and that already handles that. So I want to quickly get to the point where we're talking about the Ceph-specific versions of this. So rather than go into all those details anymore, let's say, yeah, okay, I think I just said all these things. I forgot. This actually, well, probably should have put this slide at the end. I'm sorry about that. This basically highlights if you were going to build an add-on package for Ceph that provided ADNN connectivity, it would need to do these things. The bottom line is it's just a daemon that runs everywhere. It doesn't really need anything new from Ceph. There's already mechanisms to add daemons that are monitored and they can listen on cluster state. And so that's the good news, is that this would just be a daemon that runs on every OSD node. So let's see. Right. So just jumping back to here, the idea is that the alternative to ADNN, if you want to connect to NVMe to Ceph RBD with NVMe Fabrics, you have the same problem you have with iSCSI or anything else. The normal solution is set up a gateway. So there'll be a host somewhere on your fabric that all the traffic goes to, and then it forwards it everywhere else. And so when you use ADNN, that second hop is eliminated. We also see a couple of other advantages. We have, well, first of all, we have constructed an ADNN reference implementation in SPDK, and it has all the components you need to connect it to RBD images. This is obviously not production ready. It's just a data path and the minimal configuration tools you need to set it up for one image. And I can show you in a minute that we did that and we proved that it worked. And we also showed that that an ADNN host uses less CPU cycles than that same host running at least kernel RBD. And for various reasons, when I did this POC, I stacked the ADNN stuff on KRBD rather than the RBD BDEV. Long story short, I needed to show multiple things with one experiment, and that's how it had to work. If you were going to build this for real, you would use the RBD BDEV that SBDK provides. So at the bottom of this slide here, you can see this URL, which is an RFC patch in the SBDK Garrett. And the one under it is a README file that explains this whole thing in text, so you don't have to look at this PowerPoint. So what I really wanted to get to in this presentation is how this connects Ceph and how we get away with not having live RBD in our hosts. I think it's summarized by showing you what an ADNN host knows about a DVM that's when it's talking to Ceph as what does it actually see? This JSON file over here on the right on this slide represents what it gets. So those, remember from the previous slide, all these hosts are going to see a bunch of targets. They're going to see the namespace that is exposed to them. We expect that your targets would use blend masking, right? When a host connects to it, it would say, yes, you're authorized to connect, and it would look up in a table and say, and here's the namespaces you should see. And when it does list namespaces, those are the only ones it would see. Any storage array will do the same thing. I have to point out that the SBDK NVMe Fabrics target doesn't actually have that feature yet, but lots of people want it, and it's proceeding independently. So when your hosts connect to these NVMe Fabrics targets in Ceph nodes, they're going to get a location hint that describes their volume. And it's going to be the hash hint, which looks like this structure, this JSON structure on the side. The important parts, this thing called label isn't actually something that the host will use. It's in this blob of information so that when we need to regenerate it, when something changes in the cluster, we can make it consistent. So there's no magic here. What it tells the host is this namespace bytes and object bytes tells it how to turn an LBA into an object number, and the object name format tells it how to make the name of that object, and then the hash uses. And for Ceph, that's going to be the Art Jenkins hash and the Ceph stable mod function. So what a host does is for every IO, just determines which object number it is, gets the name for that object, runs that through the hash function, runs it through Ceph stable mod, and then looks it up in the hash table. The hash table is, of course, just a simplified version of the PG table. So inside Ceph, you get a PG, and then you do the rest of crush to figure out which of those things is where your data should go. So for ADNN, since we're only talking about block, you really can only deliver IO to the up primary anyway. So that's all we tell it. We determine with the Ceph CLI tools which OSD is the up primary, that PG, what host is it in, and then what's the name, the NQN of the ADNN target in that host. And that's all it needs to know. So this hash table basically contains buckets, which are indexes into the table of NQNs. If you change the number of PGs or you add an OSD or something fails, you need to regenerate this hint, put it back in the redirectors in the targets, and then they will send it to the hosts with the ADNN mechanism.
Is that table present in every hint, or is it deduped across all of the hints for a particular pool?
So we simply, okay, so Yes, it'll basically every redirector every redirector in the OSD nodes will have this entire hint. Now, obviously, every RBD image in the same pool will have exactly the same hash table and exactly the same NQN list. But we don't. This is the whole thing. The basic guiding principle of ADNN is loose coupling, and they'll do their best to get accurate placement information, but if they don't, it needs to work anyway. So that means all the redirectors in the OSD nodes send the entire thing. If you look in the implementation
a larger
of
cluster
ADNN,
this on.
Sorry, what?
A larger cluster have you tested this on?
8 virtual nodes with 1 volume. So it's early days.
How many PGs?
There were 128, or were there 1020? I don't know.
Yeah,
I honestly can't remember. I have the file somewhere. I can tell you.
So
the PG table size, that's a concern because this all has to fit in a log page. But one of the reasons that the hash table is just indexes into the NQN table is because of that. Because there's really no bound on a PG table size, right? Now there are reasonable constraints. It doesn't do the user any good to have an enormous number of PGs. Obviously, they're all objects that have to be tracked. We all know this about Ceph, right? But for various reasons, you get really scary numbers from the PG calculator, right? It says if you've got a rack full of
you actually
nodes,
need that though for large clusters.
You need 30 or 320,000. Okay.
Hence my question: have you considered deduplicating the NQN table?
Yes,
that
was what I was getting to. The NQN table and the hash table,
I think.
So when these things are communicated, I don't really have the details. Wasn't expected to go into this detail, but hints are sent to hosts in an NVMe log page. It's a page that has a bunch of small structures in it. The hash hint is one of those small structures, but because it has these enormous tables, that hint contains other log page IDs. So the NQN table is in a separate log page, and the hash table is in a separate log page. So this means that if you're a host using several volumes on the same Ceph cluster, you only need to read. They're all going to have the same tables. So those log pages are designed with a digest. They have a header, and the header has a digest. So if you've seen, if you've already read the hash table for one of your ADNN logical namespaces, and it had all 320,000 buckets, and you've remembered what the digest for that version of that table is, then when you connect for another volume and you read the header out of the log page and it's got the same digest, you just use the same table.
Thanks.
Right, and the same thing for NQN tables. So there's some when you connect this to the NVMe or Fabrics world, there are some corners of the envelope that aren't going to maybe work so well. If you've got 10,000 nodes, that's a lot of NVMe or Fabrics connections, and if you're trying to use an RDMA transport, that might not work well. Obviously, this works with NVMe over TCP as well. But anyway, so there's tuning things. It's also true that if you've got images in separate pools, then hosts really only need to know about the targets in the nodes that have OSDs that they will actually use. So that can be managed too. All right, so let's just quickly go to how we proved. So does anybody have any questions about how we abused Brush here? We're only doing hash and mod, and all the rest of that happens in a script somewhere else in the cluster, and it's packed into this JSON structure, and then we don't update it unless cluster map changes. Or obviously,
Scott, could you explain how you abuse the NVMe protocol? I mean, Ceph is not a simple read-write. There is a read with some parameters which you cannot pass. Are you using read buffer instead of read?
Sorry, what? I mean, we basically only support reads and writes. We don't. What other operations would?
RBD read is passing some parameters which you cannot pass inside NVMe read.
There's an endpoint on the OSD nodes that actually does the RBD part, right?
Yes.
So the natural next step would be to extend the OSD to be able to speak this protocol directly.
Well, you could do that. What we assumed is that you would just run a daemon in your OSD nodes, and that daemon literally links to librrbd. So,
right.
So our only job with
yeah,
ADNN is to avoid that second fabric hop. We still, all the work of RBD still has to happen, and the hosts aren't doing it, so it happens here.
What I meant is that it adds additional CPU overhead.
Yes, it does, and that may be a showstopper for some customers. There's other customers that are just thrilled to get that out of the host.
I didn't mean that it's a showstopper. I meant that a way to avoid that would be to embed more of the intelligence of the OSD. But,
yep.
Yeah.
Yes, it would. I haven't gone there because that's pretty intrusive into Ceph. And so first we decided, let's see if anyone cares. but yeah. Sorry, go ahead.
But before that, how do you pass the information associated with a read request? I mean, read request has some non-standard information in Ceph. It's not a simple SCSI NVMe read protocol.
Well, what's an example of that? I mean, we ignored all that in our write-back cache.
The original write or read operation, however, is a perfectly standard read or write.
Yes.
It doesn't become a Ceph thing until it hits the OSD host.
Exactly.
At which point a thing on the host interprets the NVMe OF command in whatever form that is and turns it into a Ceph thing.
I think that snap and all the snap and clone, they are based on some kind of sequence number coming from the RBD.
Yeah, and in this context, the VM host never sees that.
Yes.
We don't support snapping and cloning in this model.
No,
Not from the host itself.
You would,
Yeah,
but the name of the RBD image, for instance, doesn't change under those in that case. You're still reading and writing to the same logical volume. Those things would simply happen in a management layer.
Yeah, if you change a snap, your name doesn't change, but your ID does, right? You make a new image.
Oh, that's excellent. But
copy on write, there's a version number associated for every object that you should know if you should read from
another way to
the base image. Sorry?
Another way to put it is that the VM nodes in this case aren't actually running RBD. They're sending commands to another node that is running RBD. In this case, the OSD node itself.
The initiators are dumb, and the targets have all the logic, and you had some management layer that already told the targets that these clients are accessing this image at this snapshot or whatever.
It's like
just like
iSCSI.
Exactly, except that we don't have a second fabric hop. Except in iSCSI, you send it to a host who does RBD and sends it again. Here, one hop, and you move that CPU utilization to these OSD nodes.
Right. Well, yeah, one fabric hop, but you still have the loop back right now. Like,
yeah, sure. There's right, and
you're running the RBD code on the OSD.
Yes.
On every OSD. Yeah.
Yes.
The RBD client.
Yes.
Right.
Now that may not work for you.
You're adding an extra load to the client.
We are.
We're CPU, but not network.
Yep. So here's the results of our POC. Was we showed, we're comparing conceptually these three cases, and if you can see, this is 3 runs. This network at the top is my Ceph network. This network at the bottom is my NVMe Fabrics network. We do it here with just RBD. Obviously, all the traffic is right here. All these traces in Grafana are all my 8 OSD nodes and my 1 client. In this case, we left the client with NVMe Fabrics, and we went to one of the OSD nodes, which then just delivered it over with RBD. So you can see that almost all the traffic is still on the Ceph network, and it's also here, again, on the NVMe Fabrics network. And then in the ADNN case, we put the hash hint. Now, in this POC, the redirectors weren't actually, they weren't capable of passing the hash hint in log pages. I hadn't written all that marshalling code yet. So I just configured the hash hint in the host, which obviously is not much fun to do. But the point of this whole graph is that we have no Ceph network traffic because this pool is unreplicated. Otherwise, you'd still, of course. This obviously ADNN isn't going to do anything about your replication traffic. You're just trying to get rid of that latency and the overhead of that extra fabric hop. And keep, as Jason said, keep your hosts as dumb as you can possibly make them. So dumb as a box of switches, basically, is the whole idea. So we also wanted to prove, or see, actually, whether this really saved any CPU overhead. And in my little toy virtual cluster, which was just barely large enough to show any of these benefits, but a whole lot easier to set up than a real one, when you need to actually get somebody to pay for 8 or 16 nodes and let you keep them for 6 months. The differences are wrong screen, sorry. So this is RBD at 30K IOPS, and this one over here is ADNN, same workload, same 30K IOPS. And these two red arrows indicate that the CPU utilization on that client dropped by that much. Not a huge amount, but measurable. Whether that matters to you as a customer depends who you are. And again, 30K ops is not a lot, and these were really small virtual nodes. And we probably don't have time to go into it here, but this actually represents two kinds of CPU utilization. There's normal OS thread stats, and because ADNN is an SPDK app, we have to extract thread idle time because they're always busy from SPDK, and then transmogrify that into a unified CPU utilization stats. So that's what all these caveats here are, is that this is a derived number, bind from 2, and I have the scripts that'll show you how you can do that if you care. I'm only mentioning it because someone that just reads this slide will say, hey, wait, but why isn't that nailed at 100%? It was. So we looked inside.
You have the corresponding change in CPU for the OSDs?
Sorry, what?
You have the corresponding change in CPU for the OSDs?
I didn't measure it like this. I didn't show it on this graph. And of course, I've lost the Grafana. Okay. But here's the line here. It said, we did see this 7% of one core on each OSD node, and these are 8 virtual core nodes. So yeah, there was measurable CPU utilization increase on those nodes. Now, it wasn't quite as much as we expected. Let me see if I left that slide out.
Wait, so your redirector that lives on the OSD node, that's not using SBDK running at 100% CPU?
It is. It is. So it would have had to have been monitored. It's just not shown in this graph, is what I'm saying. I mean, I did capture that data, but I didn't save it out as an image for a PowerPoint.
All right. Yeah, so the 7% overhead is if you out the busy loop spinning of.
But you do have one core nailed up. Yes, exactly.
So capacity rather than usage, perhaps.
Yeah, probably would have been a better way to say that. And whether that's okay, whether you want a poll mode application at all on your OSD node is a totally valid question. And so
Crimson's going to work the same way. I'm not worried about that.
Which?
At least I'm not. Crimson, the new OSD.
Oh yeah, right. That's
that's
what we expect.
Yeah, but you wouldn't want necessarily like one redirector stealing work or CPUs from your Crimson.
Located it within the
exactly. They would have to be using the same.
It's not actually another core. It's just a difference in capacity.
Exactly. If you can have put it in the list of poll functions that poller does, great, fine, as long as it happens. And all of this was done with kernel networking. I didn't use DPDK networking here. It's just, it wasn't important for this POC, and may or may not want to do that in a real Ceph cluster anyway. So it's orthogonal. You could use user mode networking or not. We expect most people will not.
Smaller difference in CPU utilization expected, to be honest.
Sorry, what?
This is a smaller difference in CPU utilization than I would have expected. That RBD graph, is that the utilization simply due to RBD, or is that total node utilization?
This is total node utilization. So this includes
what
FIO.
Else is the node doing? Okay, so this is the remainder of it is FIO. So
yeah,
it's RBD plus the FIO plus RBD minus RBD plus this ADNN thing is like what? There's 25% cheaper. 30%.
25. We are saying it saves you half of one core at 30K was the units we were pitching it to the customer that was interested in this. I'd have to think about it before I would make that general percentage statement that you just made.
Sure.
The other thing to note here is this sort of tortured POC. I think I left that slide out, but in even with just plain RBD and ADNN, it wasn't actually just plain RBD. It was always going through an SPDK app. So we had an SPDK app that exposed NBD, and we ran FIO in user mode to get to that. And then we either went directly to kernel RBD out of the bottom of the SPDK app, or we went to NVMe Fabrics to go to another node, or we went through a redirector to go to one of the 8 nodes. So all of the NBD overhead was always there. All of the leave the SPDK app to go to KRBD overhead was always there. The only thing that changed was what we did in the middle in the SPDK app. So we think that, nets out all these other things. Now, you would not actually build it that way, but
that's the RBD case. The ADNN case, however, was direct to whatever PCI Express shader thing.
Well, we still went FIO to an MBD device into the SPDK app.
Yeah, but
So,
that's all overhead inherent to the system.
Yes,
The RBD difference,
yes.
however, just RBD itself.
And the test setup to get the right numbers out of this thing quickly.
Sure, but again, all of that's common. So
Yep,
the delta
that was
is
the idea.
RBD.
So we think it saves some, and we're not quite sure why. And we were also surprised by the overhead numbers. We were even more surprised. I think I left it out that the latency. Did I put that in here? Back to here. The latency, paradoxically, write latency got lower with ADNN than with just going to KRBD. We don't understand why. Exactly the same amount of RBD work had to happen. We just did it on 8 nodes. So is that the answer? And this is queued up 64. So maybe that is the answer. Maybe they were just use hotter cache, and so they got better performance. And when you queued up 64 at one node, fell off the cache cliff. I don't know, but that was the result. Now I wouldn't count on this in production, right? This is probably an artifact of this test setup. But that's what the numbers said. So we're just reporting them. So that was weird. Was there another question in there that I skipped over, or did we? Let's see.
Another question that I'm not sure we talked about yet regarding the redirection. With any of these kind of setups where you're sending I/O from the client to a separate system and then going into RBD from there, if you were changing the kind of, I don't know if you want to call it a gateway, but the node that's receiving and translating that into RBD, is there any kind of handling of like when that changes, trying to avoid sending the same I/O request again, or making sure that I/Os that were already in flight don't cause correctness problems if they're still continuing?
Let's jump back to this. This diagram, this is the first one we talked about, where the two different I/Os, one with a clue, with first one without a clue, and the second one with a clue. What we don't show here is the responses. So the idea is that if you're a host, you initiate an I/O to one of your targets. If it has to forward it, it's initiating an I/O to the target it knows it should really go to. This I/O is still in flight the whole time. So when it completes here, it completes back to here, and then it completes back to here. So if, for instance, this guy died while this was forwarded, then yeah, in theory, there could be an I/O in flight here from this.
That would be really common with stuff.
But if the target has to die for that to happen, so
or you need a path failure at 1, right? Like you said, it's in flight. It gets to storage node 1. You have a path failure, so it can't ACK it.
Yes.
It times out. It redirects it over, and there's a possibility for.
Yes. If it was already in flight. So there's a couple of things we haven't really. So from the host's point of view, it didn't finish. So this redirector, so the application doesn't know about any of this, right? You gave the I/O to this redirector. The redirector knows there's multiple alternative targets for it. And its job, if it tries it here and that doesn't work, is to try it on one of the other ones.
Will it delay I/O2 until I/O1 completed?
Yes, if it knows that so whether this host delays I/O2 until I/O1 completes is up to this application. We expect that most applications don't submit. Well, if the redirector has them both, it will not. It doesn't do overlap detection.
Of ordering. Okay.
No, that's so we did that in RWL. We had to do overlap detection for ordering because we were replicating, and we need to make sure that the replicas are all identical. So we can't let those two, the race happen twice and resolve differently in different places. Now our basic position is that if you're an application and you issue concurrent writes to the same place, that's a bug. You probably shouldn't have done that. And because most block devices in JBOFs and storage arrays don't give you any kind of guarantee at all.
So in any event, it maintains a buffer of uncompleted writes, and it will resend them if it gets a
Yeah, they're just basically it's a VDEV
Yeah.
IO, and it's not complete until it completes to one of these targets. If it doesn't complete, then they try it on a different target. So and so the only race happens out here. I tried it here. This guy died. This guy had it already. He's got it in his queue or it's in flight. He probably knows that this guy has died, but it may not be cancelable, right? So it may actually complete, and then nobody will find out about it. But this guy never got a confirmation that it happened, so he's going to try it again to this same place. So
have you done the thing where the redirector on the OSCs unmounts and remounts the RBD on the other place?
Sorry, say that again.
So the redirector here, if we move, for RBD at least, the movement of an RBD image from redirector 1 to redirector 2 means unmounting it in one place and remounting it in the other, right?
Well, it's mounted in all of them.
For this to work, it has to be every single target has every single possible RBD image mounted.
Right, because they're only going to handle the IOs. Ideally, you're only going to get the IOs that go to OSDs in your node, and the others will go somewhere else. So we don't. So we have done some. I think maybe you might be talking about is what happens if something changes in the cluster and the parameters here change. Right, and so I contrived examples where at first I gave it a hint where I deliberately mangled this hash table, and you start up IO, and then when you go back and you look at this graph. Here, it doesn't look beautiful like this because the host has the wrong idea of the hash table.
Correctness, so that I understand the properties. I'm not worried about the performance yet.
Okay, but then when you update the hint, then the host applies it, and they start sending IOs to different place. So the idea is that there is no correctness issue because all of the targets in the OSD nodes can complete any of the IOs. If you send it to the wrong target, it still completes. You still give it to LibRBD. It still does the right thing with it. It just takes longer. So that's the whole idea, is that the correctness part, that this whole reason we stress this DVM abstraction is everything about making storage correct is the DVM's problem. The hosts try to get it to the right place, but if they don't, it works anyway. It just sucks a little bit.
It makes certain optimizations impossible. So if you don't use this system at all, then a particular RBD image has exactly one client. Set up this way, however, every RBD image is mounted everywhere.
Right, you have to make it be shareable.
There are optimizations we might choose to do that can't be done in that context. That's
like caching.
I'm not worried about caching because the application is where the caching should be done. That's fine.
Right, I agree.
But for instance, a particular image will have operations from many different clients. So if we wanted to do something clever, like remember only the most recent client ID that did an operation to a particular object, that's impossible.
Yep.
So there are disadvantages to this approach.
There are disadvantages, and there are more disadvantages.
Another way of doing the redirector would be that you maintain the exclusive mapping and actually move it. And your redirector, instead of simply running the RBD operation, forwards it to the one that does have the RBD image mounted. And that is an optimization we could
do that,
but
yes.
It would be more complicated.
So Ceph is kind of a beautiful example of a very simple DVM because, like we said at the beginning, normally a DVM's job is if the IO comes to the wrong place, you got to get it to the right place somehow. And systems we consider doing this in, like a pairwise HA JBOF with a PCI bus in between them, that's pretty easy in that case because everybody can see all the SSDs, right? The minute it becomes a bunch of boxes, a bunch of commodity servers on a fabric, suddenly you got another fabric hop involved. But in Ceph, you don't have to do that. Also, a normal DVM needs to very closely manage these what we call egress redirectors to make sure that they all have perfect knowledge of where everything goes because they're the source of truth. And in the Ceph case, in this implementation of the Ceph case, that's kind of relaxed. We could be kind of sloppy about it because all we care about is performance. And what you're talking about is tighter integration where you're more tightly integrated to other RBD performance features, and then suddenly that would matter. And we think the architecture allows it, but that's not what I built. Now, the bad news is it kind of gets worse. As you guys have all probably realized by now, this thing is only talking about the hash function for, if you have a clone stack, the hash function only talks about the top, right? And everything under it. So that means if you've got a clone that differs by one object from its parent, all the IO is going to go to the wrong place and Ceph's going to have to forward it because ADNN doesn't know about that right now. If you decided to do striping over RBD objects, I don't know how popular that still is, but obviously that's not going to work here. But they could.
Honest, that might not be a big problem. An actual disadvantage of RBD clones that operate like that is you get hot read zones. And because RBD clone data like that is immutable, if each of the redirectors chose to simply cache the frequently accessed blocks, you would actually reduce load on the hot nodes and stuff, which might be a net positive.
Funny you should mention that, because that's actually my straw man proposal is you should turn on the shared object cache in all your egress redirectors. And the reason I don't usually say that out loud is because then people say, wait a minute, I have to have SSDs in there that are just caches for stuff that's on my other OSDs. What? You're just trying to sell me SSDs. Yes, we are. But yeah, you're right. It would. And it's probably a the cost equation for the customer, right? To decide whether they care that much or whether they really just want to move their caching up and down.
I honestly meant just in-memory caching. They're immutable, so it's free.
Oh, okay. Well, sure. If you've got enough memory for that, yes. But to really handle clones and stripes would, need a much more sophisticated way of combining the hints in the hosts. And we've deliberately drawn a line here and say, no, let's get this out here and see what people think with this sort of minimum viable system, right? We can all think of ways that we can combine these hints. And I can tell you, I've spent some time thinking about it, and there's no super simple way to do it. There are ways to do it, but they're all kind of over the line of complexity that you'd like to have in a version 0 or something. So we're not doing that. And so if you are a person who wants to look at whether this works for you, you'll have to understand those limitations, basically. So, and as you say, turning on caching in your targets will help tremendously.
How frequently do you expect that it will make sense to trade client-side CPU for OSD-side CPU?
It'll certainly make sense if you're so the basic motivator is if you're a cloud provider and you're billing people for cycles in the hosts, then if you're spending those cycles on anything in your infrastructure, that's money.
Yeah, but you can account for them separately.
You can, but
and the OSDs are expensive too. It's not like they're free.
That's right. We would of course be happy if all your OSD nodes were 2-socket Xeon servers and had plenty of CPU. Obviously, that's totally obvious.
I mean, if it was a bare metal environment, you put all this initiator logic in a smart NIC and call it a day.
That is the poster child case. Is you'd like to do bare metal provisioning, you want to be free to give it whatever storage works for you. It makes sense, or it's at least handy if it can see the world as a bunch of NVMe devices. And that interface means it can be very performant if you put very expensive storage behind it. And with this, it'll still work if you put something more capable and flexible and a lot cheaper behind it. So,
okay, fair enough.
Now it's tempting to say, well, how would you migrate things? How would you unify that kind of system so you can have an NVMe JBOF and Ceph and maybe migrate volumes back and forth? That's clearly out of scope. But
so, did you consider actually running Crush to generate the hints?
Well, we sort of do.
No. I mean, on the client side, you distribute the actual cluster map.
Yeah. Okay. So that's kind of over the distribute. Well, then we have a RBD client essentially.
No,
so
you just have Crush.h.
There's a bunch of issues with. We already had this issue with the Ceph stable mod function is as of yesterday public domain, but before that it was LGPL. SPDK is BSD, so we can't just bring Ceph code into here. There's something I'm not prepared to talk about here yet that would be very flexible. Basically, hosts could define their behavior.
I'm just saying the weakest element of this for replacing like the general case RPD one is large clusters. Your PG set will become large at that case. And every OSD map update, whether it's incremental or large, will result in a large-scale repopulation of the PG set, which will be pricey. By contrast, if the initiators knew how to speak Crush, not a problem.
Yeah, they sort of incrementally generate it as they need it. Yes, it's true. Yeah. We have to generate that hash table once. Now, when we showed it in this,
you have to generate
JSON
every
file,
time the OSD map changes.
Yes, every time the OSD map changes, but you've got hundreds of images and maybe thousands of clients, but you really only need to generate these two things once when the map changes.
Large.
And because those log pages have digests. Hosts.
Yeah, you only have
really
to
only
download
need
it once.
to be able
That's totally
to read
true.
it once.
Yes. But incremental maps.
But they do. Yes, they do have to repopulate their hash table in their logic path. It doesn't seem to be that big a deal. You just reload the table, and the next batch of IOs
it's linear
a different
in the
copy
size
of the hash
cluster.
table. The size is an issue. Yes. How big is it? And that when we talk about putting this in pieces of hardware, that's a real problem. And so, so if you're talking about hardware accelerating this, you get to a point where you got to make a choice and say, well, if your PG map is 1,000, we can definitely do that. If it's 500,000, sorry, you're going to go to the slow path. We're going to have to do this, the software data path. When you think about a hardware offload for ADNN, you always have to have the software path there for the things that the hardware can't do. If this becomes standardized in NVMe, there'll be a table somewhere that says here are the hint types you can have. In version X of the spec, there'll be N of them, and in the next version there'll be more. Your hardware or the firmware in your device or your OS may not understand those. So
there are other approaches to this too. I've suggested in the past that it's sort of irrational for an RBD device to be spread across an entire OSD cluster. If we could constrain the placement to just a subset of the PGs, if, for instance, to get the parallelism you wanted on a particular NVMe or on a particular RBD image, you needed 64 or 128 nodes, then you could just constrain that.
Make a pool.
RBD image to just that subset of the PG space. That would be another approach to solving this problem.
Oh, you mean, okay, so you don't mean make a whole separate pool with its own PG.
I mean
just
that you give it
it
a mask so that depending on exactly where it is, it's constrained to a subset of the PG space. That would be another approach.
Yes, that would be, and it would be really easy to, basically this hint, well, you could completely hide that in whatever generated the hint, right?
It would be identical to this hint. That it's just that the hash table would be sparse. Only some of the PGs would be represented. Only the ones relevant.
Lots of buckets would point to the same place. Now, it'd be great if you could make that PG table smaller, but you really can't.
No, I mean you could make it insensitive to the size of the cluster. That's the goal.
To the number of nodes.
Smaller, exactly.
Right.
It would be constrained.
Right. Yeah, I don't think those are obstacles at all. Frankly, the things like handling clones. Actually handling all the layers of clones is fairly complicated. I mean, it's fairly
but it's complexity you'd be happy to leave on the OSD node, right?
It is, exactly.
I mean, there's no particular reason why you have to be hyper clever about it. We're talking about immutable objects that are highly cacheable.
We're trying to resist the temptation to be clever about this. So, right. It's ideally, like Jason said, we'd like to be able to run it in a very constrained environment and basically abstract the storage to hosts, so you can have a bunch of dumb bare metal tenants. It seems to us that the attack surface is reduced. You do that too. You no longer have to have your hosts be authorized to make Rados connections to things. They can only do NVMe things. So they don't have to have the keys. They don't have to have, they can't really view the state of the cluster at all. They just see block IO. That may or may not be important to you as a customer. But, let me just go back to, we're probably way out of time. Sorry, I was late. My calendar had this meeting at its time it has been at for years, and even though Josh told me it was actually at 8 my time, I didn't notice that. So where we're at is this reference implementation is out here. We only have the SPDK Lego block. You could imagine you might like to try this with a kernel ADNN client. Well, we haven't written one of those. There could be one, but kernel development is so much fun that we're getting all the bugs out of this way. The beauty, from my point of view, as the only guy working on this right now, is that I built one of these and you use it everywhere. So I didn't have to make a client and a target. There's only one thing. So like I said, it's out there as an RFC patch. Its future is, not yet determined. It's kind of large. And so when we consider adding things to SPDK, we only do that if they have real users and there's a real, it's part of products and we can justify the cost of the burden. There's also some NVMe ecosystem issues. So ADNN essentially does what you call a shared namespace. We have a namespace which you can see from multiple subsystems, and although I didn't think NVMe prohibited that, it turns out it actually does. So one of the things that breaks in NVMe is you can't do reservations on it. You can't do other things that have been defined since I started this. Basically, NVMe over Fabric's multipathing, or actually it's NVMe multipathing. It's called ANA. That won't work with these. But my position is that you almost don't need it because you've got multiple targets. You can handle loss of a path. It's not as performant as ANA, which really has two paths, the same thing. But I was going for a different use case here. Reservations may or may not be important. Now, this reference implementation doesn't implement that, of course. The real issue, if you're an NVMe person, the things that a distributed or a shared namespace presents problems for are the NVMe commands for namespace management. And those are the things that, create and destroy namespaces in actual SSDs. Now, if you're making a distributed storage system, you're not going to manage volume creation that way. It doesn't make a lot of sense. So is that these targets just won't support those commands. They're optional commands anyway. So, but bottom line is there are standard extensions in progress for what they call dispersed namespaces. And I apologize for ADNN's name. I didn't know about the dispersed namespaces technical proposal when I started this. Actually, it started well after this. And it specifically addresses all of these issues. For other reasons, storage vendors would like to be able to expose a namespace from multiple subsystems. Their sort of headline use case is migrating between arrays, and administrative, maintenance tasks like that. For if you're doing that, you need that capability at least temporarily. And so if you're an NVMe person and you look at those standards and you see dispersed namespaces, you might think, oh, that's the same thing. No, where this is probably going is if that TP proceeds and is adopted, then ADNN would naturally stack on top of that. You'd say, well, you use ADNN with a dispersed namespace, and it adds these capabilities, which are essentially just a bunch of log pages and their contents defined and the behaviors the hosts recommended. So that's kind of where we are now. Is the code is there so that people like that might use it and might want to reconcile it with the ecosystem issues can contribute and comment and tell me what works and what doesn't. But we don't have a package for Ceph yet, and it isn't really time to do that, I don't think. But and in fact, since that's not part of Ceph that I have worked on, where did I? Let's back to this slide. So at some point, I would consult like you to say, well, how this must be integrated into Ceph. Somebody wanted to create a package that added a Ceph ADNN capability. How would you do that? Would you use the iSCSI thing as a model? Is there a better model now? Sort of my question to you. What should be looking at there or targeting as the method for doing that?
Jason, how does SYSLOG look like today in terms of a model for this type of thing?
I mean, it's a standalone product, right? Project. So you have TCME runner and you have like the Ceph iSCSI packages just because they're not tied into a Ceph release. Ceph provides the core functionality, and they runner and Ceph iSCSI are just clients to whatever, to a lib RBD, lib Rados package that gets installed with them. Because there's no like one-to-one feature tie-ins. This is not like the Octopus release of iSCSI. It's iSCSI that might be using Octopus clients. So they're distributed and kept separate on in GitHub. Also, the fact that TCME runner is not just a Ceph project. RBD is just one backend for TCME runner.
Okay. So that's one way to think of an ADNN adaptation layer would be it could be a separate package that just uses normal Ceph libraries and does its thing. And that would kind of limit us to the architecture we have here, where we just use RBD in the OSD nodes. If we wanted to do anything trickier,
right? Yeah, if you're gonna have to, if one day you get some, if you get something where it's going to be co-located inside the reactor of Crimson or something like that, yeah, that's a whole different.
But that's also tremendously.
Now you're not talking add-on package. You're talking
exactly, yeah. So I mean,
I don't think you're really talking about that yet, anyway.
It's exactly,
that already kind of works than it is to like insist on being distributed.
Yes, I'm only asking that question now to make sure we don't make what probably makes sense impossible, right? Not like we're going to build it tomorrow or that we need. But I'd hate to do something if that makes sense to you all, then I will endeavor to.
Well, I mean,
it gets in the
a number of things here are tough. Like the hints don't scale properly with the size of the cluster, so that could be a real problem. There would be a lot of asterisks, caveats, and wherefores with at least the basic version.
And I do want to ask.
Well, the hints don't scale. So you mean
he's just talking about the size of the data.
Yeah, I'm saying there are architectural challenges with this.
And then the other question I have is, in Fabric spec, like how many namespaces can you really have per target?
Yeah,
if you're effectively exposing every single RBD image that's being used somewhere on every single target, at what point do you run out of quote-unquote namespaces?
I can't remember if it's a 32-bit number or a 16-bit number, but obviously the real limit is going to be an implementation limit of whatever framework you're using. You are free to have more than one target, or more than one subsystem. Now that so you can pack them a number of ways, right? So the reason we talk about it as one is that's the minimum number.
Right. Yeah, I'm just trying to get the cloud scale here, and you have, tens of thousands
and thousands
of RBD images in use concurrently that are now mapped across every single OSD node where you.
I'm all right. About that part.
So, and I think really, unless you get to the point of, what Sam mentioned with like, a given RBD image, it can be down to a given subset of PGs.
Right.
But then you start doing that, it's like, well, is this really then just a gateway? Unless you could do that PG restriction thing.
The two major pieces would be somehow restricting the number of PGs a node can map to, or changing the overhead of the hints. In addition to, you probably can't, in general, map every image on every OSD. That's extreme. So you would need some mechanism to only map on the OSD they're supposed to be the target for, with support for moving them.
Yeah, but that means you need the ability to restrict an RBD image to a certain set of PGs.
No, those two things are independently useful. You can do one without the other.
Not sure,
but I think both are required.
That I got the point where.
But at the end of the day, I really don't think it's going to scale if every single OSD node needs to open every single possible image, right? I think we all agree to that.
I mean, it depends on the size of the cluster. Like if the entire project is to make a 10-node cluster really fast, then sure, no problem.
We see a lot of 32-node clusters.
Yeah, but not thousands.
1,000-node clusters, in our experience, are not that common.
Not with very expensive
you guys see a different set of
hardware. No, it's more complicated. Stuff gets used across a lot of stuff.
Right.
But you were asking what would be like the architectural changes that you would make as it becomes more complicated. And I think this is what they would be. But for the simple version, I don't see a reason why it would necessarily need to be included in Ceph.get. Like an external project seems fine. This doesn't have a hard dependency on any particular version of Ceph, and it doesn't know anything about the Ceph internal protocols. As that becomes more useful,
if you're trying to
become different.
Yeah, that the things you might do to eliminate or reduce the RBD overhead in the OSD, integrating it to Crimson somehow in some way that makes sense. or at least maybe optimizing that transport connection to say, well, if you're talking to your local OSDs, maybe we don't need all this encryption. And,
even that could be done within the
yes.
client. You would just tell the client, by the way, you're likely to
Yes.
connect the local connections.
Right. You could maybe thing off to the side. That's kind of, so these things, we're not, there's no immediate plans to try and do any deep integration. We figured we would wait until there was a clear need. And the feature set, took out. So that, unless there's any more questions, is basically that. I did point you at the, hang on a second, where did it go? I wanted to point out this README file here at the bottom. Oops, waiting for that to do that. Clicked on it. Rather than a PowerPoint, some people would rather read an explanation of how it works to the scripts that do all this stuff. It doesn't sound like any of that's a big mystery. Ceph people understand that you can get all this information out of the Ceph CLI tools in JSON form, and that's what we did. Obviously, there are smarter ways to do it and ways you could do it less often. But so let me know if there's any, you know where to find me. If there's any questions, or you want to try it, or you do try it and it doesn't seem to work. That's about all I had to say.
All right, thanks, Scott. Very interesting stuff. I think that's all we had for today. So thanks everybody for joining, and we'll see you next month.